Let me do a problem to solve an equation using Newton-Raphson method. Example. Determine the positive root of x cubed minus 5x plus 3 equals to 0. Correct up to 3 decimal places using Newton-Raphson method. Solution. Let the function f of x equals to x cubed minus 5x plus 3. Step 1. In step 1, find the derivative of function f of x, which is 3x squared minus 5. And then in step 2, to identify the initial value. Take this function f of x. If I put the value of x equals to 0 in this equation, I will get 3, which is greater than 0. If I try x equals to 1 in this equation, I will get minus 1, which is less than 0. But if I try x equals to 0.5 in this equation, I will get the value 0.625 greater than 0. I won't take 3. I will prefer 0.625. Just ignore 3. Take minus 1 and 0.625. Why I didn't take 3? I'm gonna try to get the smaller value less than 0 and smaller value greater than 0. So the smaller value, which is greater than 0, is 0.25 compared to 3. Therefore, I prefer 0.625. So a root lies between 0.5 and 1. These are the 2 points where the root exists. And the initial value is 0.5 here. So I will proceed it further now from the equation of the Newton-Raphson method. Let me simplify this equation here. Where the value of f of x sub n is x cubed minus 5x plus 3. F prime of x sub n is its derivative, which is 3x squared minus 5. Take its LCM to get the final value, which is x sub n plus 1 equals to 2x sub n to the 3 minus 3, or 3x sub n to the 2 minus 5. This is my new equation of the Newton-Raphson method. Now I'm gonna do the iteration process here. Take the equation and substitute the initial value here, which is 0.5. So this is my x sub n. It is the approximate value of the first iteration process. Repeat the process again and substitute the value of x sub 1, which is 0.647. This is my x sub 2, which is the second approximate value of the second iteration process. Repeat the process again and substitute the value of x sub 2, which is 0.646. This is my x sub 3, which is the approximate value of the third iteration process. You can see here that x sub 2 and x sub 3 have similar values. And therefore, I'm gonna stop the process here, because once you reach to the stage where the last 2 iterations have similar values, then the process has to be stopped. So I got these values x sub 1, which was my first approximate value of the first iteration process. X sub 2 was 0.646, which is the second approximate value of the second iteration process. X sub 3 was 0.646, which is the third approximate value of the third iteration process. I stopped the process because the last 2 iteration processes match each other. Look to the diagram here. This is my x sub 2 and this is my x sub 3, which is the positive root. If the values of x sub 2 and x sub 3 are below the x-axis, then the root is negative. But here the root is positive.